All right, let's practice the chain rule by doing this worksheet. Okay, so the derivative of y, dy dx, is the derivative of the big picture. So we have something to the negative 2 power. The power rule applies. We bring the negative 2 down and raise the something to 1 less, and the something stays the same inside here. But then we have to take it times the derivative of the inside, and the derivative of x squared is 2x by the power 2, this to 1 less, and the derivative of 9x is 9. So we take the derivative of the big picture, negative 2 times this to negative 3, times the derivative of the inside. That's the chain rule. So this is the cube root is all of this to the 1/3 power. So this is 9 plus 5 e to the 5x squared plus sine 2x. So the big picture is something to the 1/3 power. All of this to the 1/3 power. So dy dx is going to be 1/3 times all of that stuff unchanged to 1 less power, which is negative 2/3. 1/3 minus a whole 1, or 3/3, is minus 2/3. That's the derivative of the big picture, but then we got to go times the derivative of the inside. Derivative of 9 is 0. Derivative constant is 0. Derivative of, now this is a chain rule in itself. The derivative of e to something is e to the same thing times the derivative of the something. And the derivative of 5x squared is 10x. So the derivative of just this piece is all of this. And the derivative of sine of something is cosine of the something. But the something is more complicated than just x, so we got to take the derivative of 2x, which is 2. That, all of that is the derivative of this. Not pretty, but that's the idea. Not the idea to make it not pretty, but the idea of how to do it. All right. So the big picture here is we have the tangent of all of this. So the derivative of tangent is secant squared of whatever the tangent was of, which was sine x times cosine 3x, times the derivative of the inside. And the inside is a product. So we have to do a product rule. And the product rule is the derivative of the first. So the derivative of sine is cosine of x times the second plus the derivative of the second. So the derivative of cosine of something is negative sine of the something. In this case, it's not just an x, so we have to take the derivative of that, which is a 3. So that's the derivative of the second times the first. And that would be the derivative of tangent of sine times cosine of 3x. Messy. Just checking to see if you know how to do your derivatives. Okay, so here we got y is secant of a quotient. So we've got a big picture secant. So the derivative of secant is secant of whatever it was of tangent, derivative of secant is secant tangent, so tangent of whatever it was times the derivative of the inside, which is a quotient, so we're going to have something minus something over the denominator squared. Derivative of the numerator. Derivative of 3x squared is 6x times the denominator plus the derivative of the denominator. The derivative of x plus 2 is 1 times the numerator over the denominator squared. So the derivative of the big picture secant is secant tangent of whatever it was times the whatever it was derivative. Now, one that's a little trickier. We're going to work with tables and just numbers. So I'm not telling you what the functions are. We're going to try to find the derivatives just by looking at the graphs. And we don't really need to see the graphs, but I asked you to graph it in 5 on a 0.2 by 0.2 grid. So that means if you put your x in the middle and your y-ish in the middle, x, y, and go by 0.2, 0.4, 0.6, 0.8, 1, 0.2, 0.4, 0.6, 0.8, 2, 2, 4, 6, 8, minus 1, 2, 4, 6, 8, minus 2. Go from minus 2 to 2 so we can get it all on there. And if we go by 2, 4, 6, 8, 1, 2, 4, 6, 8, 2, 2, 4, 6, 8, 3 would be up here at this height. Minus 2, 4, 6, 8, minus 1, 1, 2, 3, 4, minus 2, 1, 2, 3, 4, minus 3. Didn't get it quite centered, but that's what we're going to try to graph. And some of this is going to go off graph, but that's okay. We're going to draw f of x. I'll do it in blue. So at minus 2, it's f of x is 0.42. 0.2, 0.42. At 1.8, it's 0.23. 0.03. Those were minus. Minus 0.42. Minus here, minus 0.3. So if we get those other ones, 2.3 is right here. Not there, there. Then it's 1.7. That's a little less than 0.2. 0.36. That's almost 0.4. 0.54. 0.2, 0.4, 0.54, 0.7, 2, 4, 6, 7, 8, 7, 8, 3, 8, 3, 9, 2, 9, 2, 9, 8, 1. Nine, 8, 9, 2, 8, 3, 8, 3, 7, 5, 4, 5, 4, 2, 3, 6, 1, 7, negative 0.3, negative 0.23, 2, 3, negative 4, 2. So that's f of x. Pull in my red and try to do g of x. Minus 2, it's at minus 8. It's off the graph. Minus 5 off the graph. Minus 4 off the graph. Minus 2.674 at 1.4. Minus 1.2.4. Minus 1.4, it's at minus 2.24674. Minus 1.2, it's at minus 1.24673. Then it's at minus 1, at minus 1, at 0.8, it's 0.51, 0.22, 0.06, 0.01, 0, 0.1, 0.6, 0.6, 0.22, 0.51, 1, 1.7, 1.24673, 2.24674, and then I'm off the scale. That's g of x. Okay, that's what these look like. If t of x is f of g of x, find t prime. So if you're trying to find the derivative of a function inside a function, you take the derivative of the big function at g of the function times the derivative of the inside. We did a problem like that. So, what is g of negative 0.6? G of negative 0.6 is negative 0.22. That's g of negative 0.6 is negative 0.22. Now, negative 0.6. Negative 0.6. All right. Now we're going to find f prime of negative 0.22. f prime at negative 0.22. F prime at negative 0.22. Well, there's close to it. That's what f is. What's its slope? So if we want the slope at this place, we can look at the central difference theorem. We can look at the slope from either side. So I would take the bigger one, so y2, so I'd go, this would be 1.00 minus 0.92 over 0 minus a minus 0.4. That's roughly the slope at negative 0.22 of f times the slope. This was g at negative 0.6. So at negative 0.6, I have to get its slope, and I have to multiply them according to the chain rule. So the slope here, I'm going to go a little bit beyond it. So negative 0.06 minus a little bit before negative 0.6, here, negative 0.51, over negative 0.4 minus negative 0.6, 0.8, going either side of negative 0.6. So this is going to be approximately the slope of f of g of x of t at negative 0.6. So 1 minus 0.92 is 0.08, over 0 minus a minus is plus 0.4 times, let's see, negative 0.06 plus 5.1, so that'd be 0.45, I believe, over, and negative 0.4 plus 0.8 is 0.4. So we get, pull out a calculator. Where did I put it? Over here. So we get, actually I probably should type this whole thing in here. So parenthesis, 1 minus 0.92. Can you see that? There we go. Close parenthesis divided by parenthesis 0, subtract negative 0.4. All of that times parenthesis negative 0.06 minus negative 0.51, close parenthesis, divided by, parentheses are really important on here, negative 0.4 minus negative 0.8, close parenthesis, and we get 0.225. If I didn't make a mistake. Easy to make a mistake in there. Now it says r of x is the composite f of g of x divided by f of x. So this is a quotient. So r prime of x is the derivative of the numerator, f of g of x derivative, the derivative of this, times the denominator, minus the derivative of the denominator, times the numerator, over the denominator squared. Okie dokie, messy. Well, we just did f of g of x prime. And that was 0.225, if I didn't make a mistake, times f at negative 0.6. Negative 0.6, f is 0.83. Minus f prime at 0.6. Let's see, did we do f prime at 0.6? No, we haven't. So we're going to have to do central difference theorem to find f prime at negative 0.6. So we're going to go 0.92 minus 0.70 over 0.4, negative 0.4 minus a minus 0.8. Negative 0.4 minus a minus 0.8. That would be an approximation of f prime times f of g of negative 0.6. G of negative 0.6 is negative 0.22. Negative 0.22. And we've got to find f of negative 0.22. Well, negative 0.2, f is about 0.98. All over f of negative 0.6, which is 0.83. 0.83 squared. So I got to figure that out. So I got a parenthesis for the numerator. 0.225 times 0.83 minus parenthesis for the numerator, 0.92 minus 0.7 divided by parenthesis negative 0.4 minus a negative 0.8, close parenthesis, close a parenthesis for that whole thing, times 0.98, close the numerator, divided by, and I can put parentheses, but I'm squaring it, so 0.83 squared, and I get negative 0.511. Now I'm going to tell you how I made these tables. F of x is just the cosine of x. Does this look like a start of a cosine curve? And g of x is x cubed. Does that look like an x cubed? So now let's find them using that we know the functions. Let's check our answers basically. So f of g of x. F is cosine of x of g of x, so we got to put x to the third in there. So that's f of g of x. So its derivative, the f of g of x derivative is derivative of cosine times the derivative of the inside, which is 3x squared. And we're supposed to do this at negative 0.6. So now I'm going to go to my calculator and just type that in. Let's see, I'm getting a lot of reflection there. Let's move it there. Negative sine of parenthesis. Oh, no, don't need it. Negative 0.6, close. I do need it. Yeah, get back there. I need insert a parenthesis. I got to take the negative 0.6 to the third. And then close the parenthesis on the sign. Times 3 times negative 0.6, close parenthesis, squared. And the exact answer, not with all these approximations, is 0.231, which is, this is our estimate using the tables. Here's the correct answer. And now we got to take the derivative of this. So the derivative of this is this mess, but let's just figure out what this is. So this was this divided by cosine x. So g of x is this cosine x to the third divided by f of x, which is cosine x. So its derivative is the derivative of the numerator, which we did here, minus sine of x to the third times 3x squared times the denominator minus the derivative of the denominator, which is negative sine x times the numerator, cosine of x to the third, over the denominator squared. So we got to get this with x at negative 0.6. Now, instead of doing it the way I did here with all these parentheses, that's a pain in the rear, I'm going to go to y equals. I'm going to clear that. I'm going to start off by typing the function in. And you can do this on Desmos, call it f of x or something, but I'm going to go alpha y equals so I can get a fraction and type in negative sine of x to the third, close parenthesis, times 3x squared cosine x, close parenthesis, minus a negative sine of x cosine of x to the third, close parenthesis, that's my numerator, over parenthesis cosine of x squared. So there's that. And then I'm going to quit. I'm going to go to my table and type in negative 0.6. And it says working this out at negative 0.6 exactly is negative, or more exactly, 0.5 529, which is close to what I got by doing the approximations off the graph. Messy stuff, but that's how, if you didn't know the equations, you just have data. You just have data. This is how you have to work with the data to try to figure out rate of change of these functions, these complicated composite functions or quotient functions, and it's a lot of work. Okay?